Hello there, welcome to a linear relationships video on sketching lines from other equations. By other equations, well, we can often be asked to sketch lines when a linear equation is not in the form of y equals mx plus b. We just saw a previous video on sketching when the equations are in the form of y equals mx plus b, but let's have a look when equations are in other sort of forms. So here we're asked to sketch a linear equation 2x plus y equals 3. Now that's not in the form of y equals mx plus b. So the method is, method 1 anyway, I'll show you two methods today. Method 1 is we just rearrange this linear equation so it is in the form of y equals mx plus b, because the great thing about y equals mx plus b sort of formats is that we can read off the y-intercept and the gradient and sketch the curve sketch the line pretty quickly. So let's rearrange this. Now to rearrange it, you can see that y equals mx plus b has y totally on its own. So we need to rearrange this original equation we're given here so that y is on its own. So we'll need to take away that 2x from that left hand side so that y is on its own. Now if we do that, we'll need to take away 2x from the right hand side as well. If we want to move something using algebra to solve equations or move things around in equations, we need to do the same thing to both sides. So on the left hand side, the 2x will be having 2x taken away from it. They'll cancel each other out. We can kind of think of that original 2x as being a positive 2x, so that's why we're subtracting both sides. It's not a very good plus, is it? But anyway, so when we do that, that 2x is gone on the left hand side, just leaving us with y on its own. And now you can see that that equation arrangement has been moved to be in that y equals mx plus b arrangement. And once it's like that, we can do a lot. We can then sketch it like we did in the previous video. We can plot the y-intercept. That y-intercept is plus 3. This number here is our y-intercept. So we can put that straight onto the number plane there. And we can also then go ahead and do the rise and the run. Now we look here at the m here for the rise and the run. This isn't in fraction form. So what we'll need to do is think of that as being in fraction form, as in minus 2 over 1. Any whole number we can put it over 1, because then we've got a rise of 2 and a run of 1. And we also need to keep in mind that because that m, that number in front of the x there, has a minus in front of it, we know that this line leans to the left. This was all in that previous video, so you can go back and check that if you like. It's called sketching lines using y equals mx plus b, but I'm going a bit quicker now because I'm assuming you've seen that video and you know what you're doing. So we rearranged that original linear equation into this format, and we're learning the three things we need from that to be able to sketch. So we've plotted the y-intercept of plus 3. If we do the rise and the run there, we rise 2 and we run 1, and I've deliberately run to the left hand side here because I'm expecting to have a left leaning line when I join those dots. So I join the dots and I label the line. Now it's important here to use the original form in the question. Sure, we rearranged it into y equals mx plus b to help our thinking and to help us position this on the number plane, but the original question asked us to sketch 2x plus y equals 3, so that's the way we're going to label the line, 2x plus y equals 3. Use the original format there. Okay, so we're asked to sketch this. Let's have a look at another method we could use. This isn't in the form of y equals mx plus b, but we can use another method to sketch this anyway, and that is to find the x and the y intercepts. So to find the x-intercepts, we sub in y equals 0 into the rule here. So x-intercepts happen when y equals 0. So when y equals 0, now we're going to replace y with 0 in that linear equation, and on the left hand side you can see that we're kind of left with just the 2x, and on the right hand side we have a 3. Now at this point here, to move that 2 that's kind of invisibly multiplying here, we'll divide by 2 on the left hand side and divide by 2 on the right hand side, and so that'll leave us with x equals 3 over 2. that divided by 2 and that multiplied by 2 will cancel out on that left hand side, leaving us with just 3 divided by 2, which can be written as 3 on 2. Now just to help our brain there, we'll just convert the 3 on 2 into 1.5 into a mixed numeral there, because we're going to plot that on the number plane in a minute. Okay, so how did we find the x-intercept? We subbed in y equals 0 and we just got x on its own. Okay, the second step is to find the y-intercept. Now for that, we've got to substitute in x equals 0 into the rule. So the y-intercept happens when x equals 0. So if we replace the x with a 0, we'll have 2 lots of 0, which is 0, plus y equals 3. So on that left-hand side, when 2 lots of 0 equals 0, we're left with y equals 3. Not a lot of solving or rearranging needed there to get the letter on its own. So we've discovered a y-intercept there of 3. So we'll collect that x-intercept of 1.5 and that y-intercept of 3, and we'll use that to position this line on the number plane. Okay, there's the number plane. Here's our steps for that. We'll plot the x-intercept of 1.5. Now we'll go on the x-axis halfway between the 1 and the 2, obviously, for 1.5. So that'll be plotted down there. And our y-intercept is a 3, so we'll plot the y-intercept on the y-axis, logical place for it. And we've created 2 dots there. We'll then join the dots and label the line just on top there. Okay, so we've found the x and y intercept by subbing in y equals 0 and x equals 0 and just solving that little resultant expression. And we've plotted those 2 points and positioned that on the number plane. So that's method 2. So let's to recap here. We can, I know it's not in y equals mx plus b form, but we can, using method 1, rearrange it into that form carefully to get y on its own. Then we'll go through the points there, plotting the y-intercept, and from there doing the rise and run and figuring out whether we want the line or we expect the line to lean to the right or the left. We'll join the dots and label the line and make sure it's in original form, not just in our rearranged form. The second method we saw was that we could find the x and y intercepts by subbing in y equals 0 and x equals 0 and doing a little bit of getting of the letter on its own. We'll plot both of those and then we join the dots and label the line. Okay, now just a little word of warning that some of the rearrangements into y equals mx plus b might be a little bit harder than the example I chose there. So let's see a slightly harder example, and just there's a little bit of a cautionary tale in there. I'll warn you about something halfway through this example here. So if we wanted to get y on its own here, I might indicate that we want to move terms away to get y on its own. If we want to rearrange it into y equals mx plus b, notice again that in y equals mx plus b we have only a y on the left hand side. We've got a lot more on the left hand side at the moment. So we'd have to move terms around to get y on its own. We'd move them away from the y. Now when we move terms, and when we're solving equations, we move terms by doing the opposite operation to both sides. So let's have a look. Now I'll put the y in red there to show you that we need to move the 2x and we need to move the 3 at some stage to get y on its own here. So to move the 2x, we will be taking away 2x on both sides, and that will cancel out on the left hand side, leaving us with 3y on that left hand side, and we'll just write out minus 2x plus 6. That's what's happening on that right hand side. They're not like terms, so they can't be simplified any further on that right hand side. One of them's got an x and one of them hasn't, so that's as best we can do. We'll just list them beside each other there, minus 2x plus 6. Now we then have to move that 3. Now that 3 is invisibly multiplying between the 3 and the y. So to move that, we'll need to do the opposite of that. So the opposite of timesing by 3 is dividing by 3. Now we have to do that on both sides. Now here's the bit we have to be really careful of. When we're doing it on the right hand side, dividing by 3, we'll need to divide by 3 for both of those right hand terms. We'll need to divide 3 into the minus 2x and divide 3 into the 6 as well. Be really careful with that bit, otherwise this won't work out correctly. On the left hand side, the multiplying 3 and the dividing 3 will cancel each other out, leaving us with the y, which is exactly what we want. We wanted that y on its own, didn't we? Now on the right hand side there, let's have a look. What happens when we have minus 2x divided by 3? We can just write that down as minus 2 thirds x minus 2 over 3. A dividing by 3 can be written underneath as a fraction. So 2 divided by 3 is really 2/3. So we'll just write it like that. And then 6 divided by 3 is just our 2 there. So we've eventually got it into the y equals mx plus b format. We had to move a 2x and we had to undo a 3 that was multiplying. We had to be really careful. This is probably the key bit to what I'm talking about here. On this right hand side, if we're dividing that right hand side by 3, it's got to happen to each of the terms there, not just one of them. Now, seeing we've got it into y equals mx plus b there, to plot that, we'll just go pretty fast here because you've seen this a number of times already. We'll plot the y-intercept, and this is where we look for the y-intercept. So the y-intercept will be at +2, so I'll put a blob there. Okay, and then from there, I'm going to do the rise and the run. My rise is 2, so I'm going to go up 2, and my run is 3, so I've got to go across 3. I'm also keeping in mind that I want to be ending up with a left-leaning line. So instead of going to the right 3 places and looking at this point over there, I'm going to the left 3 places and looking at that point there. So I'm going to rise 2 and run 3 so that I get the correct lean on my final line. It's really bad coloring in, but still. And so that's where I will be having my 2 points. This was my y-intercept. I rose 2 and ran 3 because of that 2 over 3 there. It's rise on the top and run on the bottom. And then I'll just label the line there with the original, not the rearranged. Notice I used the original version to label the line. Okay, so that's how to respond when we're trying to sketch lines that aren't originally in the y equals mx plus b format. We can either rearrange it to make sure it's in the y equals mx plus b format, or the other method, of course, that we saw was to find the x and y intercepts, plot them, and then join the dots for that. Hope that helps. It's a bit trickier from just getting a y equals mx plus b format, but not too hard. We just got to keep our wits about us. So watch the video again if you need to. That's how to sketch lines from other equations. Thanks for watching. I'll see you again sometime. Remember, for any of your maths needs, plenty of great videos on peterblakemaths.com. See you next time.